Before we start work on ellipses, we're going to take a moment and connect something we've done in the past with creating a system of equations to find the equation for a curve to something that we're doing now, which is working with circles and parabolas and conic sections. What I want you to do is start by trying 66 part A. You're going to push pause, you're going to do the best you can, and either when you get done and you're ready to compare your answer, or when you get stuck, then go ahead and push play and you'll be able to see me working out the problem. So a circle contains the points 0, 6, 6, 8, and 7, 7. Now we need to remember that contains means none of these points is the center. They're all points on the circle. We're asked to find the equation by solving a system of 3 equations. So if we think about the equation for a circle being x minus h all squared plus y minus k all squared equals r squared, we can realize that we can create 3 equations, each of which replaces x and y with one of the points that we're given. So the first equation would start out as 0 minus h squared plus 0 minus k squared equals r squared. And if we simplify that equation a bit, we'll have h squared plus k squared equals r squared. My second equation would be 6 minus h squared plus 8 minus k squared equals r squared. And simplifying that one's going to give us a bit of a longer equation. Squaring the first binomial, we get 36 minus 12h plus h squared. And simplifying the second binomial, we get 64 minus 16k plus k squared equals r squared. Now we're going to want to simplify that a little bit more in a minute, but let's get the other equation written down. So the third equation will be 7 minus h squared plus 7 minus k squared equals r squared. And squaring those binomials like we did in the second equation, we have 49 minus 14h plus h squared plus 49 minus 14k plus k squared equals r squared. All right, so let's take a look at these. We might notice that there are h squareds and k squareds in all 3 of the equations. And so we might want to set things up so that they sort of lend themselves well to substitution. So let's simplify these equations just a bit more. I'm going to start with the h squared plus k squared. Notice that's taking these 2 terms. And then I'm going to keep with my order, and I'm going to have minus 12h and minus 16k. So that takes these 2, leaving me with 2 constants on the left. So that's going to be a total of 100 equals r squared. I'm going to simplify the second one in the same order. So I'm going to have h squared plus k squared, and that's going to also be followed by negative 14h and negative 14k. 49 and 49 is 98, and that equals r squared. And now I'll just pull this one over so it's in the same place as all the others. All right, we're trying to take our 3-variable system down to a 2-variable system. So since we know that h squared k squared is equal to r squared, there's actually a couple of different ways we could do the substitution. But I'm seeing h squared k squared here and here, and that makes me want to put an r squared in their place. Now, at first glance, that's not going to solve our problem. So the other option would be instead to take and replace these r squareds with the h squareds and the k squareds. And notice that does solve our problem. It eliminates the r out of the problem. So that's probably the best choice for this substitution. So these 2 equations will become h squared plus k squared minus 12h minus 16k plus 100 equals h squared plus k squared. And similarly, the one below becomes h squared plus k squared minus 14h minus 14k plus 98 equals h squared plus k squared. So although these equations are quite long, they at least only have 2 variables now, and there are only 2 equations. We also notice that they can get shorter quickly. H squared from the left cancels with h squared on the right in both of the equations. K squared on the left cancels with k squared on the right in both of these equations, and we suddenly realize we have 2 linear equations. So I'm going to do a couple of things. First of all, I'm going to write them the way a system of 2 equations would normally be in a standard form. So I'm going to move those constants onto the right. I'm also going to try to simplify them. So I noticed that 12, 16, and 100 are all divisible by 4. So I'm going to divide them both by 4 as I bring it into a normal form. So I'm going to end up with negative 3h minus 4k equals negative 25. As I look at the bottom equation, I'm going to do the same thing with the order, and I notice that 14, 14, and 98 are all divisible by 2, so I'm going to divide each of those by 2. Although actually, I'm realizing they're also all divisible by 7, so I think that would be an even better choice. So if I divide by negative 7, I'm going to have 2h plus 2k equals 14. Oh, which means it looks like I could have gone even further. I could have divided them both, all 3 times by 14. So let's take that down. And we'll divide each of those by 2 now. So I'm going to have h plus k. It's going to give me a 7. So now when I look at these, I realize either the h's or the k's need to match. So if I multiply the bottom equation by 3, that will give me 3h plus 3k equals 21. And when I add that to the top equation, my h's eliminate. I have negative k and a negative 4. So I can see that k equals 4. And suddenly there's a light at the end of the tunnel. So we're going to work our way back through the problem. I can put that into the h plus k equals 7 and see that if h plus 4 equals 7, then h must equal 3. So I'm getting close to having my equation. I now know that x minus 3 squared plus y minus 4 squared equals something squared. And I need to find out what that something is. So it's time to use that simpler equation, h squared plus k squared equals r squared. So 3 squared plus 4 squared equals r squared, or 9 plus 16 equals 25. We've now found that equation. Now, just to be sure that this worked, I plugged this into Desmos, and so I'm going to take and show you that image. If you look here, you can see that that circle, x minus 3 squared plus y minus 4 squared equals 25, does in fact go through the 3 points that we were given. So that verifies that 66A works. Okay, let's take a look at 66B. Like we did before, pause, try B on your own, and then come back and check your work against mine. So in 66B, we're told that there are actually quite a few different parabolas that go through those 3 points, which is contrary to what we learned back in Unit 4. But remember in Unit 4, we were only talking about quadratic functions, and there's only one parabolic function which passes through these 3 points. So this process you've done before, and I think won't be as difficult for you. So we would be using y equals ax squared plus bx plus c. And when we plug in that first point, we very quickly see that we already know the y-intercept. We know that c is equal to 0, which immediately takes this from a system of 3 equations down to a system of 2 equations, so much more manageable than the last problem. So we can now plug in 8 and 6. We don't need to add in the plus c because we already know that c is 0. And this simplifies into 36a plus 6b equals 8, which further simplifies, since all of those are even numbers, into 18a plus 3b equals 4. And then we can take the 0.77 and do the same, simplifying that one into 49a plus 7b equals 7. And since all 3 terms are divisible by 7, we have 7a plus b equals 1. If we take a look at that bottom equation and we divide and we multiply everything by a negative 3, we'll see that we can make it match that top equation in the b's. So we have negative 21a minus 3b equals negative 3. And when we combine that with the other equation, we have negative 3a equals 1. Dividing both sides by negative 3, a equals negative 1/3, which isn't the prettiest value in the world, but it's certainly something we can work with. We need to plug that back into one of the equations. Personally, I would take the one that we had just multiplied by -3. Seems the simplest to work with. So 7 times -1/3 plus b equals 1. If you just multiply each of those terms by 3, you can stop dealing with a fraction. So you have -7 plus 3b equals 3. Adding 3 to each side, 3b equals 10, and b equals 10 thirds. So we actually know all three values, and we can get our parabolic equation. Y equals -1/3 x squared plus 10 thirds x. Since we know that the c was 0, we don't need to write anything there. Just to verify that this was also true, I did put it in Desmos, and you can see that that equation down here at the bottom does fit through those same 30 points as the equation for the circle did before.